All right, let's get started with the first section of R2. We're going to split section R2 up into an A and a B. R2A is going to be the first four objectives, 1 through 4. So we'll run through those. All right, so we'll get started by looking at the number line. Remember what we're doing here. This is the real number line. Imaginary numbers aren't going to show up on this. And we like to always start our real number line centered on 0 and nice even tick marks between our integers. All right, so that's what we're looking for when we draw a number line. Okay, so we do have coordinates on here. Coordinate P would talk about a specific point on the number line. All right, and so again, we're going to the left of the 0. We get into negatives. We go to the right of the 0. We get into positives. And when we say the word origin, we're talking about the number 0. Okay? And that's about it for the number line. Oh, do we want to allow the program to make changes? Sure, why not? Okay, back to the important stuff here. All right, multiplying positive and negative numbers. You guys know this. A positive times a positive is a what? Positive. A negative times a negative is a positive. Wow, that just died completely. Come back, slideshow. There you go. And a positive times a negative, or a negative times a positive, both of those are going to be negative. Okay? Dividing works the exact same way. All right, let's jump into our first objective here. Graphing inequalities. Was there one we should try? Sorry, before we do that, skip this one. Number 11 in the book is yours to try. So you can pause the video, try problem 11. All right, so let's get into our first objective, graphing inequalities. All right, so we want to graph A is less than B on this one. All right, so we know here, I'm sorry, this is saying that A is less than B because A is to the left of B. All right, if A and B are on top of each other, then they're equal to each other. And if A is greater than B, then A is going to be over here to the right of B. Okay, so using inequality symbols, remember that the open eats the larger number. Now that's pretty straightforward when we're dealing with positives, but remember when we're getting with negatives, smaller numbers are actually bigger negatives. I like to think about it with money. I would rather owe somebody $4 than owe somebody $8. I am worse off if I owe $8. So that needs to be over here on the small side of the inequality. Okay? All right, and they can go both ways. You can write 8 is greater than 0, or you could write 0 is less than 8. All right, knowing those things, why don't you try 15 and 25? All right, graphing inequalities. On the real number line, graph all the numbers x for which x is less than or equal to -1. All right, so we're going to draw our number line here. We're going to put a 0. We're going to put a -1. We're going to, let's put a few extra ones just to get them in there. -3. All right, x is less than or equal. So a less than sign is going to give me, we're going to put a little circle on the -1. And then the equal here, if you remember, means we fill it in. Okay, so filled in circle, and then less than means we want to go to the left, so we're going to shade to the left. And some of you, perfectly fine, some of you like to shade. You've been taught to do that, perfectly fine. It's also okay to draw the number line, close circle, and do that. Okay, so it's drawn that way as well. Excuse me. On the real number line, graph all numbers for x for which x is greater than 2. All right, so we've got 0, 1, and 2, and we've got an open circle, and we're going to go to the right. All right, so 31 is all yours to try. Let's find distance on the real number line, our second objective here. All right, so This is all about subtraction. From 0 to 4, that's 4 units. From 0 to 3, that's 3 units. So from -4 all the way out here to 3, that would be 7 units. Just the distance, just our subtraction. All right, and what this gets into is the absolute value. Okay, we're not talking about is it to the left or to the right. Okay, just how far total. So all these answers are going to be positive if we're just talking about distance. All right, so absolute value means give me the positive value. All right, so let's compute some absolute values. The absolute value of 4, make it positive. It's already positive, so it's 4. -6, let's make it positive. So it's 6. We get rid of the negative. And 0 means that there is 0 distance between me and something, so the absolute value is still 0. Right? That won't change. All right, so if P and Q are 2 points on a real number line, do we have any problems to do? No. If P and Q are 2 points on a real number line with coordinates A and B respectively, the distance between P and Q is denoted by D for distance, P comma Q. So we subtract the two numbers and take the absolute value. So what's the distance between 4 and 7? Well, we could go 4 minus 7, or we could go 7 minus 4. It really doesn't matter, because we're going to do the absolute value of it anyway. So the answer would be 3 no matter which way you do it. So it's probably easier to do the bigger number first, so you don't have to deal with negatives when you're talking distance. All right, find the distance on a number line. Now let P, Q, and R be points on a real number line with these coordinates. Find the distance between P and Q. All right, so -4, -1, and 5. Notice that I'm just sketching here, so I'm not worried about the units being exactly equal. P, Q, and R, respectively. All right, between P and Q, that's going to be -4 minus 5, which is -9, and we want the absolute value of that, so the distance here is 9. And how about between Q and R? That's a 5 minus a -1. Don't forget those negatives. The answer here is not 4. The answer here is 6. All right, see how you do on 37. Let's move on to the third objective, evaluating algebraic expressions. All right, so a bunch of them in here. If x is -2 and y is 4, remember we're going to substitute. So 2 times x becomes -2, minus 4, y becomes 4. So we've got -4 minus 16, -20. Careful with our negatives. -3, -2, and 4. -3 times 2 is 6. Positive now, times 4 is 24. 2 times -2 all over 5 minus 3 times 4. All right, order of operations. We're going to multiply on top first. We're going to clean up the top. We're going to clean up the denominator, the bottom. 5 minus 12 is -7. So 4/7 will be our answer. 2 negatives. And lastly, some absolute value. 3 times -2 minus 2 times 4, all inside absolute value brackets. Absolute value of -6 minus 8 is -14. So the answer is just 14. 39 and 47 are all yours. All right, last objective. Let's find the domain. So the domain is all about the input. All right, so the set of values that a variable may assume is called the domain. All right, what can the variable be? All right, so find the domain of the variable x in the expression. All right, so x can be any number except for 1. There is one number that x can't be. Think about this for a second. All right, so it has to do with the denominator. You can't have 0 in the denominator. So x minus 1 cannot be equal to 0, which means that x cannot equal 1. Right? Because 1 minus 1 would be 0. Wouldn't work for us. So the domain, we're going to write it like this, is the set of all real numbers, okay, such that x does not equal 1. Now, we usually write this as a shortcut, just saying x cannot equal 1. We're assuming we're dealing with the real numbers. All right, either one of those is going to be just fine. All right, let's talk about the circumference of a circle. And the formula for the circumference of a circle with radius r, the domain of the variable r representing the radius is the set of possible positive real numbers. Okay, not negatives because you can't have a negative radius. All right, so we could write the domain of r, x is greater than or equal to 0. Right? You can't have a negative radius. The domain of C, representing the circumference of the circle, is also the set of positive real numbers. So it would be this again because you can't have a negative circumference. All right, so using that information, see how you do on 57. All right, and that's it. Good luck on that, and we'll go over anything that you don't understand in class. Good luck.